Hello guys, this is Arshad here. First of all, we are going to discuss about undetermined coefficients today, and here we are with example. We are going to solve it with the method of undetermined coefficients. First of all, what you do is actually you find the root of this particular part of the differential equation. What we have been doing before was that take this part is equals to 0 and then find its roots actually. So we are not going to waste your time and we will do it directly. So the roots for these equations comes out to be, okay, so the yc comes out to be c1e to the power 4x plus c2 e to the power minus x. So this is our yc. Now basically what we have to do after this is finding the yp of this equation by the method of undetermined coefficients. Okay, so what we are going to do is we are actually finding the coefficients of this differential equation. So first step will be y is equals to a sin x plus b cos x. So we are actually interested in finding the coefficients of whatever a or b is. So we'll take derivative of this y. First derivative, this becomes a cos x minus b sin x, and its second derivative will become minus a sin x and minus b cos x. So we are going to put all of these back into this equation and solve for a and b. Okay, so we are going to put these back into this equation. It will become, we are putting this in place of this, it will become minus a sin x and minus b cos x. Okay, now in original equation we have minus 3 multiplied by first derivative of y. So we multiply 3 by this first derivative of y. Okay, so I'm going to write them. It will become minus 3a cos x plus 3b sin x, and now we have minus 4 multiplied by our original function. This is our original function, so it will become minus 4a and sin x minus 4b cos x. If we add up all these together, I'm just gonna add them directly, you can figure out yourself later. So it will become minus 5a plus 3b sin x plus minus 3a minus 5b cos x, and this, all of these is equals to this function of x. Are you getting it? Equals to 2 sin x. So how do we solve for a and b? Okay, so now we will actually compare the coefficients of both sides. Here we have two functions, sin and x, and here we have one function. There's another function actually, of course, cos 0 cos x. We can write it as 0 cos x. So we'll compare the coefficients of both the functions. So this coefficient of sin x will be equal to the coefficient of this sign, so it will become minus 5a plus 3b equals to 2. And what do we get else? Yes, minus 3a minus 5b. This coefficient of this cos is equals to this. If we don't have anything here, it will be automatically, we can write it and multiply by it by 0, so it balances the whole equation. So it will become minus 5 equals to 0. Okay, so these are basically two equations, so we can solve them, so simultaneously solve them actually. So you can just, I am just directly writing and you can do it by yourself. So we have two equations and two unknowns. We will solve it by simultaneously. If we solve it simultaneously, we get the value of a as minus 5 upon 17 and b comes out to be 3 upon 17. So what was our original function? This was our original function, right? So we are going to put these values in back into that equation. It will become 3 upon 17 cos x. Okay, so this, our yp comes out to be this. Now the overall solution is equal to yc plus yp. What was our yc? Our yc was c1 e to the power 4x plus c2 e to the power minus x and minus 5 over 17 sine sine x plus 3 over 17 cos x. So guys, this is our solution. I hope that you understand well. Do some more practice and try solving some problems by yourself. I hope you will face no difficulty. If you just have to take care of the calculus and the calculus and the algebra that is being used in this equation, that is the most difficult part. If you memorize the method properly, there will be no difficulty. Okay guys, see you later.